When I first wanted to develop a microcontroller course for 32-bit, I first started looking at the Arduino Due, which is a 32-bit ARM Cortex-M3. And as most Arduino boards, it has a standard kind of configuration here for shields, but it also has some extra pins, and I thought this was great. But the problem is that even though the Arduino libraries are available, written in a language called processing, they really do not allow you the ability to troubleshoot right down to the hardware the way you would want. So what you really need is a JTAG, or Joint Test Action Group connector here, to allow you to peek and poke around at the addresses and do real troubleshooting instead of just sending messages to the serial screen. Now this one is one from Black Spirit Technologies called the Black Magic Probe, and as you can see, it's approximately $70. And unfortunately, it's not supported by Atmel Studio. Atmel is the one that makes the Arduino Due, as well as a lot of the 8-bit Arduino type boards. And so the only one that's supported there is the SAM ICE, which is basically $100. Used to be $150, now it's down to $100. So it's very expensive because the board itself is about $50 plus $150. This is $70 plus 50, it's $120, so at least $120 to program this where you can actually troubleshoot it properly. Or if you want to use Atmel Studio 6.2, you have to spend about $150, and that was just a little too expensive. The next board I looked at was the Armstrap Eagle. There's a nice little symbol of an eagle underneath here. Now what we find on this board, instead of being an ARM Cortex-M3 like the Arduino Due, this is an ARM Cortex-M4. It's a little bit more powerful. And the beauty is that on here it actually has the same Blackmagic probe that we had tried hooking up to the Arduino Due, and which by itself is $70. But what we find is this entire board with a battery backed up real-time clock and a Cortex-M4, this entire board is $70. And I thought, wow, this is a pretty good deal. But then the problem was there's no Arduino-like connectors on here, there's no written libraries, and just to run the IDE took me hours and hours just to configure the IDE to talk to this, and without any libraries to deal with the board itself, it was practically useless because you have to write your own libraries, and that's not an easy thing to do. Now I was starting to get a little concerned until a colleague of mine, George Vanderbilt, told me about MBED.org. And so if you go to the mbed.org website, what you're going to find is that it's got a lot of ARM, or Advanced RISC Machine Microcontroller support here. You can look at the technology here. It talks about how all of these things, the Cortex, various Cortex and so on that we're going to be using, solutions, it shows solutions. So there's a lot of good things you can read about here: smart cities, wearables, smart home, and these are the kinds of things that most engineers want to develop for these sorts of applications. And most of the 32-bit stuff right now is about the same price as a 8-bit microcontroller. So having that extra expandability is great when you're designing products. Now let's look under platforms. And what I did here was I said, I want to have the best system out there. Now, so we went down there, and they have a number of supported microcontrollers, as you can see here, MBED, and they're constantly writing libraries for these things, which is great. So we don't have to write libraries as we would with the Armstrap Eagle. And first thing we looked at here is interface. Now, the Simsys DAP is a way of programming through a little connector on here, and it does full debugging where you can peek and poke at memory locations and stuff inside the micro and do this as you're debugging your program. So that's a very useful thing. So you don't need an extra JTAG. You just have this going right through the USB. So we want to do connectivity, USB host. Would be nice to have Wi-Fi, USB device, which will be on the go as we'll see. Bluetooth smart. Let's go Ethernet, let's go the whole shooting match here, cellular and controller area network. So we want all of those things. So these are the things that we want on our interface. Now we have different platform vendors, but more important, what we want to do is have Arduino compatibility. So when we select all of these things with Arduino compatibility and all this, these are the list of microcontrollers that it gives us. Now if we slide over here, this one happens to be an ARM Cortex M0 Plus, which is a low-end microcontroller. It doesn't have a lot of resources. As you can see here, 128K of flash, 16K of RAM, not a lot. So when you look through all these things, and I've looked at these a fair amount, I picked this one here. Now this is the Freedom K64 board. It's an ARM Cortex M4, 120 megahertz, 1 mega flash, quarter meg of RAM, Ethernet, SD file system. That looks pretty good. So I just clicked on this, and I've done a research about a lot of the other systems on here, but what I found is it's got so much stuff built in. There's the ARM Cortex M4. Over here is a micro SD connector, so you can hook up to gigabytes to make file systems and stuff out here. It has the Ethernet connector, so you can put an RJ45 and talk out to the internet. It has over here 3D accelerometer. It's got an RGB LED, a couple push buttons, some other stuff. And as we go down through here, it shows us all the different pinouts, and you'll notice this is 3.3 volts, which is standard for most 32-bit microcontrollers these days. And it shows a lot about subsystems and so forth. And as we keep going down here, it talks about things like all the different devices. We got an RGB LED and all these kinds of things. It talks about that. And when we take a look down here, let's just take a look at the features. Let me see if I can zoom in just a little tighter. So it's got 3 SPIs. Serial peripheral interface or serial synchronous. It's got 3 I2Cs and I2S, 5 UARTs, a USB on the go, a USB regulator, pulse width modulation, A to D converter, 2 16-bit A to Ds that are muxed or multiplexed. It has a 12-bit D to A, general purpose I/O, comparator, controller area network. It's got a 3-axis accelerometer and magnetometer. It's got Ethernet, 2 push buttons, and RGB LED, and even though it doesn't come built in, it does have the ability to expand and do Bluetooth. So if you happen to click on this link, it's going to take you and show you that, look at that, for an extra $6.43 plus shipping and handling, you can get this nice little Bluetooth module that will work in one of these Arduino type connectors that you've got. Also, if you want Wi-Fi, you can click here, and for another $2.98 you can get this, which will again interface to this board through the Arduino type connectors that are on here. So you got drop and drag programming, your USB, you got a lot of stuff, and then you say, okay, give me the bottom line. How much is this thing? So if we click on the buy now, it's going to take us out and give us an idea of how much this is, and look at that, $35. $35. It's half the price actually of the connector to the Arduino. The Blackmagic probe was 70 bucks, and this board that has all the troubleshooting and everything that you don't need this JTAG for is half of that price. This is a pretty nice little microcontroller, and that's what we're going to be using for the course. Now notice what it says here, which is quite interesting. It says the flagship from FreeScale. Now the nice thing about having the flagship microcontroller system is that it's going to be supported. But for 35 bucks, full support, flagship, I'm thinking this is a pretty good deal.